Okay, so we are going to talk about significant figures and decimal places. You see, suppose we have an example like this. So we have B is 998.216 and C is 998.251, and they measure those six significant figures. Okay, so this terminology. So 6 significant figures. And then we have to find what is the relative and absolute errors in storing B and C. And then estimate the relative errors in B minus C. So when you say measure to 6 significant figures, then it just means that the relative errors in storing B are just less than 0.5, 10 to the minus 6. Okay? So suppose you have 7 significant figures, then this one should be 10 to the minus 7. Or 9 significant figures, then this one should be 10 to the minus 9, and so on. But in our case, we have 6 significant figures. So this one is 0.5 times 10 to the minus 6. And relative errors in storing C is the same. It's just 6 significant figures. So we have relative errors of C less than 0.5, 10 to the minus 6. Okay. So then when we have the relative errors, then what is the absolute errors? So the absolute errors, okay, so if you remember the formula, then the absolute errors is just the relative errors multiplied by the absolute value of B, okay? Because the relative errors is absolute value divided by absolute value of B, so we have this relation. And now in our case, we have relative errors of B less than 0.5, 10 to the minus 6, and B is a positive number, so we don't have to take absolute value, just write down 998.216, and then you can have, you plug in the calculator, you can have something here, okay? And then similarly, you can have the absolute errors of C will be the relative errors of C multiplied by the absolute value of C will be less than 0.5, 10 to the minus 6 times 998.251. And please plug in the calculator to get the results here. And now, what is the relative errors in B minus C? Okay, so if you take B minus C, just take the absolute value. Then just take 998.216 minus 998.251. And this one will give you 0.035. And you see, now you see only 2 significant digits. Okay, so remember, significant digits are the digits after the dot that are non-zero. So 2 significant digits. And you see, well, 2 significant digits are figures, so the same, yeah? So you can say either 2 significant digits or 2 significant figures. And you see, before we say that when it measures 6 significant figures, then the relative errors less than 0.5 times 10 to the minus 6. So here we have a reverse direction. So now we have B minus C have 2 significant digits or 2 significant figures. Then you can say that the relative errors in B minus C will be less than 0.5, 10 to the minus 2. So we get two significant digits. Okay. So see, the terminology we have to pay attention here is significant figures. So when you say about significant figures, then you specify something about the relative errors. Okay. So now in the next example, we look at another terminology, what is decimal places. So now suppose you have C is 101.25, but now it's measured to two decimal places. Okay. So what does it mean? So when you measure to two decimal places, then what you are trying to say is about absolute errors. Okay. So now absolute errors of C will be less than 0.5 times 10 to the minus 2. So if you replace by 3 decimal places, then this will be 10 to the minus 3. Or 9 decimal places, this one should be 10 to the minus 9. Okay? And now, once you have the absolute errors, then you can derive what is the relative errors. So the relative errors in C will be equal the absolute errors in C divided by C in absolute value. And here, because we have this absolute values of C less than 0.5, 10 to the minus 2, and you plug in the value of C is 101.25. Okay? And you will have the relative errors of C will be less than, so this one will be around 4.5, 4.9, 10 to the minus 5. Okay? And then those are relative errors. And then the rounding errors. So the rounding errors, remember we talked about it before. So the rounding errors, when storing C in the computer with a double precision will be just the epsilon times absolute value of C. Yeah. So the rounding errors will be just epsilon times absolute value of C. And remember, epsilon is the machine value epsilon. It's a gap between 1 and the next machine number, or the smallest machine number, so that 1 plus epsilon is bigger than 1. And in our case, it's a double precision, so epsilon will be 2.2, 10 to the minus 16, and time absolute value of C will be 101 times, times 101.25. So it will be around 2.02, 10 to the minus 14. So you can check the results by plugging the calculators. So to sum up, significant figures is about the relative errors, and decimal places is about absolute errors. So when you say significant figures, so when you measure to up to 6 significant figures, just means that the relative error is less than 0.5 times 10 to the minus 6. And when you say that measure up to 2 decimal places, it just means that the absolute errors is less than 0.5 times 10 to the minus 2. Okay? So we are done with this question.